So we got 2 days left to do, 2 sections left to do, section 11.8 day 1, 11.8 day 2, and then section 11.9. Today's lesson, in my opinion, section 11.8 is more difficult than section 11.9. That's why we're spending 2 days on it, obviously. But we're going to be working very similarly to what we've been doing before. Oh, yeah, sir, you want to do it right now? Yeah, I want you to set up and pull it. What's that? Yeah, you did. Just walk over. Just walk back. All right, here we go. Sorry for the delay on the video. So again, like I said, we're going to be working very closely to what we had been doing before. It's going to be very similar to the notes that we had had. Now, remember back when we were simplifying radicals, all of that was really multiplication, right? All of that stuff was really multiplication. So what we're going to do now is put 2 radicals next to each other and talk about what happens when we multiply these things together. So we can use the product property and quotient properties of square roots that we've already learned to multiply and divide expressions containing square roots. So let's jump right in. Let's take a look at this. So there's really 2 ways to think about each one of these problems. And it really kind of depends, however you want to think about it, however the problem lends itself, whatever you'd like to do. Here's the first way to think about these problems. If I've got the square root of 8 and the square root of 6, what I could do is break down the square root of 8 and break down the square root of 6 and see what happens. That's one way. In my opinion, the easier thing to do would be to multiply these things together. Here's what I mean by that. You always multiply things inside with things inside and things outside with things outside. So what are my 2 radicands here? 8 and 6, right? So that means if I'm multiplying in there, I can take the square root of 48. Because 6 times 8 is 48. See, you can either break it down first or multiply, then break it down. I think you guys are going to find that it's going to be easier to multiply, then break it down. Let me show you what I mean. This is 2 and 24. This is 2 and 12. That's 2 and 6, which is 2 and 3. Let's buddy up. Buddies. Buddies. So what should come out on the end? 4. What stays in? 3. And that's my answer. That's it. So when you multiply 2 radicals together, you just multiply what's inside, then break it down. The other option would have been breaking it down and then multiplying together. But you always have to break it down in the end. So why not just do it after I multiply? Let's take a look at another one. What if I have 2 radical 5 squared? What if I have 2 radical 5 squared? Well, remember that something squared is like this. I don't need the parentheses there anymore because it's all just multiplication. We can say 2 times radical 5 times 2 times radical 5, right? Well, what I said is I'm going to multiply things inside with things inside and things outside with things outside. Look at the things that are outside. What does the 2 times 2 get us? What does the square root of 5 times the square root of 5 get us? The square root of 25. Thank you, Elena. What is the square root of 25? 5. So this ends up just being 4 times 5, or 20. Questions about that? Let's do the same thing for the next one. So do you see the 2 radicands? Because I'm multiplying, I'm just going to multiply those 2 numbers together. And what is 3 times 12? 36. And then what is y times y? Y to the second, or y squared. And then that becomes a problem that I could have given you on yesterday's quiz, right? What is the square root of 36? What is the square root of y squared? And that's my answer, 6y. Not too bad, right? Not too bad. Definitely. Yeah, a little bit. It always turn out pretty easy. Let's take a look here. I've got the square root of 2m and then the square root of 14m. Let's multiply things inside with things inside. So I've got 2m times 14m. What's 2 times 14? 28. And then m to the second. Now, is the square root of 28, is that a perfect square, 28? No. So let's factor tree it down. So I'm going to do 2 and 14, and then 2 and 7. Do I have any buddies? Yeah, a buddy set of 2s. And then what's the square root of m squared? Just m. And then what's on the inside? My 7, my lonely 7. 2m radical 7. See, once I combine to be one square root, at that point, I'm back to what we did yesterday on our quiz. I'm back to just reducing the radical. Okay? Now, this is if there's just one radical times one radical. Let's look at the bottom of your paper there. What if I have a radical times 2 different terms? What if I have a radical times 2 different pieces on the inside? Well, instinct tells you, what should you do with that radical 3? What do you think you should do with the radical 3? Distribute. Let's do it. Now, remember, things inside go with things inside. Things outside go with things outside. Let me ask you, is 7 on the inside of a radical? No. So you don't multiply it with the 3. It just becomes 7 times radical 3. See, the 7 doesn't have anything on the inside. So it doesn't get multiplied with that radical 3 doesn't get multiplied with anything. Radical 3 times radical 8 should be what? Radical 24. That I do multiply together because the 8 was inside the radical. Now, let's break everything down. Can I break down 3? No. So that piece is done. Let's break down 24. That's 2 and 12, 2 and 6, 2 and 3. I've got a, yes, Rosalie?
Did you multiply 3 and 24 first?
No, because there's a subtraction sign in between it. Let's buddy up with a set of 2s. So I've got 7 radical 3 minus 2 radical 6. Now, can I combine those 2 things? Can I subtract those? No. They don't have common radical terms, so I have to just leave it separated like that. Why don't you guys try the next one on your own? Now, when I multiply in here and here, I am going to multiply the 2 and the 8. Why does the 2 get multiplied by the 8? Good, because they're both in the square root. So 2 times 8 gets us the radical 16. 2 times 18 gets us a radical 36. Now, do I need to do any sort of factor trees? No, those are both perfect squares. Square root of 16 is 4. The square root of 36 is 6, so I get 10. Questions about that? Mr. Spottleton. How's it going today?
How about yourself?
Why don't you guys try the next one? Try C on your own. I'll put it on top of that.
Can you switch it?
Sure.
Thank you. How's Rudder doing back there?
He's doing better. My better.
Boy, Rudder? No.
That's right. When you distribute the radical 5 into the 4 radical 3, are you going to do anything with the 4 that's sitting on the outside? No, you're just going to leave it on the outside of that term. Yeah.
So you still distribute the 5 and the 3?
Correct. Yeah. All right, so I distributed the radical 5. Pull this down a little bit. I distributed the radical 5. And remember, things inside go with things inside, things outside go with things outside. So radical 5 and the radical 10 make radical 50. And then when I distribute it over here, the 4 stays on the outside, but the 5 does get multiplied by the 3. Radical 5 goes with radical 3 to get radical 15. Now, I have to break everything down. 2 and 25, 5 and 5. So 5 radical 2 plus. Now, does anything happen with the 15? No, there's no buddies, right? So we just leave it plus 4 radical 15. And that's it. I can't combine it past that. Make sense? Okay. Let's do one more of those. Let's do this one together, because this one's kind of funky. It's got a lot of different things going on. Again, the rule is things outside go with things outside, things inside go with things inside. Right? So when I distribute the 5 radical 5 into the negative 4, for this first distribution, what does the 5 on the outside get multiplied with? The negative 4 to get a negative 20. Does the 5 on the inside of the radical get multiplied with anything? No. That stays radical 5. Same thing here, but then I go things outside with things outside, things inside with things inside. What does the 5 on the outside get multiplied with? The 6 to get a 30. And then the square root of 5 and the square root of 5 make the square root of 25. And now we reduce it down. Negative 20 radical 5 doesn't do anything. Negative 20 radical 5 stays because 5 doesn't get broken down. It just would be 1 and 5. And then plus 30 times, well, what is the square root of 25? 5. So all in total, negative 20 radical 5 plus 150. And there's my answer. Questions about that? Okay. Now, that was multiplying one piece into multiple parts. Well, what if I have two sets of these? What if I have two sets of multiple parts? This is kind of like that binomial thing that we did when we did the FOIL method, right? If I've got two different pieces there, and I want to multiply those pieces together, we've got to use this FOIL method. In chapter 7, we learned to multiply binomials using FOIL. What does FOIL stand for? First, outer, inner, last. Good. First, outer, inner, last. First terms, outside terms, inside terms, last terms, right? First, outer, inner, last. And just seeing it here, I've got two terms, the 4 and the radical 3, and then two terms, the 5 and the radical 3. When I multiply, I'm going to take first terms together, 4 times the 5, and that's where I get the 20. And then I take the outer terms together, 4 and the radical 3. Now, is there anything to combine with a 4 times radical 3? No, you just leave it a 4 radical 3. Your inside terms, same thing. Watch out here. A lot of people might try to tell me like radical 3 times 5, which is the same thing. Don't say radical 3, 5. Don't do that. Always put the whole number first out in front of the radical. Radical 3 times 5 would be 5 radical 3. And then the square root of 3 times the square root of 3 would be the square root of 9, which reduces down into 3. We always combine our inside terms together, your outers and your inners. 4 radical 3 plus 5 radical 3 would be 9 radical 3. You just put them above. And then you can combine your whole numbers on the outer terms there, 23 plus 9 radical 3. Ready to try it? Let's do it. My students today are like zoning out. I need to be doing like cartwheels up in the front of the room.
I would pay to see that.
Do one right now. He's done it before.
He's done it.
I left my wallet, so I can't pay.
You guys don't think I can do a cartwheel?
No, he's done it before.
I know. Like, how do people doubt my ability?
They're hating.
Right.
Right under that.
You honestly don't think I can do a cartwheel? If I do a cartwheel, you do a cartwheel.
No.
Don't video. No videos. Phone down, Rosalie.
Birthday.
I think it's 8.2.
What? That's a tiny cartwheel right there.
bro.
That's a tiny cartwheel.
I mean,
Honestly,
he's older than you, so he just challenged you.
Kind of just let that go.
I promise you mine would look really bad.
I know.
You know what?
Well, it's worth it.
You know,
it's a little harder to get my 6'5" frame, full extended.
What are you saying? What are you saying about me? What are you saying
Short.
about me?
That you're short.
I know. My center of rotation is a little bit lower
Yeah,
from the ground.
a little bit.
Yeah, I don't try to get in the gym and shoot jump shots.
Do they know about your hidden talent?
I don't know, do you? I don't know.
Do you guys know Mr. Laver's hidden talent?
Jump shots. Not jump shots.
Mr. Laver's hidden talent is not shooting. No, shooting you. They don't know. You really don't talk to your students about some of these things.
I was like, I'm talking about math.
Tell them what your hidden talent is.
I teach top.
Wait, really? I forgot you were on it.
Never did.
Yeah.
Do some stuff.
No.
No. Yeah,
I have actually never seen it, and I've.
You haven't really?
Yeah. It's on YouTube somewhere.
That was a mistake for saying it. There's 20
Yeah.
investigators right here that are about to.
I did it at the.
I'm gonna dedicate my weekend.
Did you really?
Tap dance. You wear like the leotard and everything? Like the tight.
What do you think?
What
Baker?
year?
What do you think,
Yes.
Baker?
What year was it?
I don't remember.
Like 1840.
1840.
Okay.
They have muskets.
It's more like 19.
We lit the pub by lantern.
Yeah.
Back then.
Okay, I want to go ahead. I want to see it.
Okay, sorry. Let's get to it. Let's go back. So 4 plus radical 3 times 4 plus radical 3. Remember, that squared means you're going to break it up into those two pieces. Now, Can I have everybody's attention really quick? Everybody, I need eyes on the board real quick. I die a little inside. Everybody tries to, anytime somebody tries to do this. Can I distribute that squared in there? No, you can't do that. Don't do that. Don't ever.
Why not, Mr. Lever?
Me too.
Just doesn't work. That just doesn't work like that. Okay. So let's FOIL. First together. 4 times 4 is
16.
Thank you.
Okay, people.
I got
outers. 4 times radical 3. Now what does that become? It's not radical 12.
No, 4 radical.
4 radical 3. Remember, we don't combine because 4 is on the outside, 3 is on the inside. So 4 radical 3. The inners, same thing, right? 4 radical 3. Now my last, radical 3 times radical 3, would be the square root of 9. Now, if you want to just jump ahead and just write 3, that would be fine as well. All right. So we've got 16 plus 8 radical 3 plus the square root of 3 is 9. Or sorry, square root of 9 is 3. So I did a cartwheel, got my brain all backwards. 16 and 3 make 19.
Did you write 6 in that box? Or never mind.
You good?
Yeah.
Okay. Let's do another one. 3 minus radical 8 plus or times 2 plus radical 8. Again, we're just going to FOIL this. Let's FOIL it together. First, 3 times 2 is 6. Now, outers. 3 times radical 8. 3 radical 8. Inners. Now, what does that get us? Minus 2 radical 8. Good. Don't forget about the minus. Minus 2 radical. Why is it minus? Because the radical 8 is minus, right? And then on the last, I get minus, again, negative times a positive is a negative. Radical 64. 8 times 8 is 64. Again, if you want to jump to straight being 8, that's fine. I'll do that in the next step. So we have 6 plus 1 radical 8, or just radical 8, minus just an 8. I take 6 times, or plus negative 8, I get a negative 2. Now, if you left that as an answer, I wouldn't be mad at you. But is there anything else I could do?
You could simplify the 8.
I could simplify the 8. And that's what I need to do. To get full points, I would need to simplify the 8. This is a 2 and a 4, and a 2 and a 2. So that ends up being negative 2 plus 2 radical 2s. That's a lot of 2s right there, folks. That's a lot of 2s.
Negative 2 plus 2 is like,
I simplified 8 with a passion trick. Yeah.
Could you not add the 2 together?
No, because it's got something attached to it. Yeah, Rosalie asked a good question. She said, okay, could you not add this negative 2 plus 2? And I said, no, because the 2 has a radical 2 attached to it, a positive 2 does.
so that's kind of like the coefficient to a variable.
Right, it would be like saying like negative 2 plus 2x. You can't combine those. Right. Let's do one more. I have this ordered a little weird, but it doesn't really matter. You're still going to do the same thing. It just might be a little bit out of order in the end, and that's okay. First, 4 times radical 3. 4 radical 3. A lot of people get really confused on that. Remember that it's just a whole number and a radical. Just take the whole number and put it in front of the radical. Outers, 4 times 5, 20. Inners, negative radical 3 times positive radical 3, negative radical 9. Negative radical 3 times positive 5, negative 5 radical 3. Now my like terms are here and here. 4 minus 5 is negative 1 radical 3 plus 20 minus 3. The radical 9 becomes just a 3. And now this is negative 1 radical 3, or just negative radical 3 if you want to, plus 17. Or 17 minus radical 3. That would be fine. So your homework tonight, page 8, 19, 1 to 18. I'm going to pull it up here on the board. You got a good 15 minutes to work on this. Oh, let me stop the video. So long, everybody watching at home. Shout out, John.